Hi, everyone. So this is a big topic back in your Algebra 1 class, factoring polynomials. Now, I don't have time to review all this in our class, but I want to give you all the resources you need. Alex will help a lot if you need review. ALEKS, maybe the tutor Alex, but ALEKS. I don't know if there's a tutor Alex. All right, anyway, let's do some examples. Let's go straight to some examples. All right. If you see something like 8x plus 6, often the first thing you want to factor out is the GCF, the greatest common factor or divisor. All right, so in this case here, 8x plus 6, if you want to factor 8x plus 6, the largest thing that goes into 8x and 6 is 2. We factor out the 2. When you factor, you do what? D word. When you factor, you divide. 8 is 2 times what? 8 is 2 times 4. What did you do with the 8 and the 2 to get the 4? You divided. 8 divided by 2 was 4. When you factor, you divide. That's a critical theme. When you factor, you divide. So when you factor out a 2, you divide 8x plus 6 by 2. 8x divided by 2 is 4x. 6 divided by 2 is 3. So when you factor, you have to factor out the GCF. It might be all at once, it might be piece by piece, but eventually you have to factor out the GCF. All right. X to the 5th plus x to the 3rd. How do you factor that? You factor out the power of x with the least exponent. What's the least exponent? 5 or 3? Which is further to the left on the real number line? Well, it's going to be the 3. There are other numbers in here, but I'm pointing out 3 is less than 5. It's further to the left. So when you factor this, you want to factor out x to the 3rd. That's your GCF. When you factor, you divide. All right. Now, what is x to the 5th? I'll do this in red. What is x to the 5th divided by x to the 3rd? We start here with x to the 5th. In a way, we're taking out x to the 3rd. What's x to the 5th over x to the 3rd? X to the, when you divide powers of x, what do you do to the exponents? You subtract them. 5 minus 3 is 2. That's why you have x squared over here. And then the x cubed divided by itself, don't worry about the 0 issue. X cubed divided by itself is 1. All right, so you need that 1. You can think of it as a necessary placeholder. X cubed divided by itself is 1. A lot of students forget the plus 1, but you do need it. All right, and then the x squared plus 1 is what we call prime over the reals. There's no way of breaking down or factoring x squared plus 1 any further where you're just using real coefficients. And 1 times doesn't count. All right. Sometimes it helps to factor out a negative GCF. Although you might want to tear it apart bit by bit. So for example here, if you wanted to factor negative 8x to the 5th minus 6x cubed, you might want to start by factoring out a negative 1 first. The GCF is larger than that, but you might want to start out by factoring out a negative 1. When you factor out a negative 1, indicated by this opposite sign here, when you factor out a negative 1, when you factor, you divide. Well, when you divide both these terms by negative 1, you're flipping the signs. There's an implied positive sign in front of the 8. And then you factor 8x to the 5th plus 6x cubed. 8 and 6. What's the greatest common divisor? The greatest common factor between 8 and 6? It's 2. What about the x to the 5th and the x to the 3rd? We just did this. Okay. What's the biggest thing in a way that divides both of these nicely? It's the power of x with the least exponent. It's going to be the x to the 3rd. So 2x to the 3rd, or you could say negative 2x to the 3rd, is going to be the GCF. When you factor, you divide. 8x to the 5th divided by 2x cubed is 4x squared. 6x, right? 8x to the 5th divided by 2x cubed. We've already taken care of the sign issue. Okay, that's going to be 4x squared. 6x cubed divided by 2x cubed is 3. positive 3. 4x squared plus 3, that turns out to be prime. If you're not sure about that, we'll discuss that later on. But in Algebra 1, you did not break this down any further. Be careful. Can you factor this like this? Oh, I see that x is a common factor of the base here. Let's take them out. Ah, that doesn't work. Not equivalent. See, here's the thing. When you factor out the x, you better put grouping symbols because the fifth power applies to all this stuff. And then both these factors, the x and the x squared plus 1, share the 5. So if you're going to take out an x, don't forget the 5 goes along with it. When in doubt, use grouping symbols. We're basically appealing to this rule here. xy all to the n is x to the n, in this case x to the fifth, y to the n. Y is x squared plus 1. All right, factoring formulas. You're going to need to know these. Be able to factor a PST. We're reversing the squaring rules from before. Remember the squaring rules from before? When we squared a binomial? Factoring reverses the multiplication rules, like FOIL and a plus b all times a plus b, right? When you square the a plus b. This is factoring going in reverse, reversing that rule. All right, so you can go from here back to here, expressing a PST as the square of a binomial. Now, we don't factor a sum of two squares using a general rule. We don't have a general rule for factoring a sum of two squares yet. We don't factor a squared plus b squared as it stands yet, but we do factor a difference of two squares. A squared minus b squared can be factored as a plus b and a minus b. If you don't believe me, FOIL this thing out and you'll get a squared minus b squared. If you want to check a factoring rule, take the result here, multiply it out, see if you get the left-hand side. You can check your proposed factoring rule. Okay, now you may not have seen these before. All right, factoring the sum of two cubes and the difference of two cubes. How do you factor a cubed plus b cubed? We do factor these, even though we don't factor the sum of two squares with a general rule yet. Okay, a cubed plus b cubed, also a difference, a cubed minus b cubed. Bottom line is you end up with these guys over here. If you don't believe me, distribute like crazy. Okay, simplify, and you'll get the left-hand sides. All right, but what's a way of remembering? All right, when you factor a sum or difference of two cubes using these rules, on the right side, you're going to get a binomial factor and a trinomial factor, a two-term guy and a three-term guy, all right? Now, the binomial is pretty obvious. When you factor a cubed plus b cubed, you might guess that a plus b is a factor, and you'd be right. If you factor a cubed minus b cubed, you might guess that a minus b is a factor, and you'd be right. Now, notice, I'll put this in blue here. When we go from here to here, the sign stays the same. S for the same sign. Whatever the sign is here, that's the sign there. What about the signs in here? Focus on the signs, all right? Here we go from, I better put this in, let's see, turquoise. Plus to minus over here it's minus to plus. So for this sign over here, it's the opposite of what we got for both the binomial guy and the original. Over here, always a plus sign over there. AP, always plus. So the signs on the right side go SOAP. Same sign, opposite sign, always plus. SOAP. My colleague Larry Foster likes to use SOAP. Well, I hope he likes to use SOAP. He's a clean guy, right? Okay. You just have to remember this. Oh, and also, there's not a PST over here. There's no 2 there. I know you're used to a 2 being there because the PSTs have 2s in front of the AB term, all right? But there is no 2 in front. So be careful. Know your signs, and there is no 2 or negative 2 in front of the AB terms. In fact, the trinomial factor tends to be prime. the trinomial factor does tend to be prime. All right, I'm assuming you've already factored out the GCF of the whole thing. Remember, if there's a GCF that's not 1 or -1, you got to factor that whole thing out anyway. Eventually, it could be in pieces. All right, same, opposite, or different, always plus. The sign's on the right side. There are many other factoring rules, and there's a handout I have. Okay, so review the handout. It's in my online notes. Can you do these 10 factoring problems, actually 12 factoring problems? The last 2 involve sum or difference of 2 cubes, right? But can you do these 12 problems? I have these 12 problems, and I have solutions in my notes. Practice those. Alex can help. Next, even more factoring.